Hey guys, and welcome back. This is part 2 of the video over rate of change in slope. In this second video, we're going to go ahead and talk about how to find the slope of a line without the graph, but just given 2 points on the line. So this is a fact that I want you to really drill into your head for this unit here. You only need to know 2 points on a line in order to find its slope. For examples 1 through 6 in the first video, I took all of my graphs of my lines and I took 2 random points on the line and I calculated the rise over the run for each of those lines. And again, it doesn't matter which 2 points you pick as long as you calculate the rise and the run correctly. So even if you're not shown the graph of a line, it's possible to take 2 points that you know are on the line and still calculate the slope of the entire line using what we call the slope formula. There's a lot of different ways to write the slope formula. One of the ways is this. We talked a little bit in the last unit about the linear function families and how the function families are in the form of the equations y equals mx plus b. That's something we're going to get into a little bit more in the next video, but one thing I want you to remember for this unit is that the variable m is what we use to represent slope whenever we're talking about the slope of a line. So if you know 2 points that are on that line, you can find this slope m by using the following formula. We say that m is equal to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. In this case, this y sub 2 and this y sub 1 stand for the y coordinates of 1 point and a second point, and the x sub 2 and the x sub 1 stand for the x coordinates of 1 point and a second point. Okay? So if you know any 2 points on a line, okay, this would be the first point right here, and this would be the second point, you can calculate the slope of that line by following this formula right here. Another way to say this formula is by saying m is equal to delta y over delta x. We used that one day in class. I told you that delta is a Greek symbol that means change. So change in y over change in x, okay, and that change, again, is another word for difference, okay? The difference in the y values over the difference in the x values, which is what this formula here is saying. So to use this formula, we're just going to plug in our 4 different coordinates we have, okay? 2 y coordinates and 2 x coordinates every time we get 2 ordered pairs, and calculate what the ratio is. So for number 7, it's going to look like this. Our slope, which again we're using an m value, is equal to the change in the y values. And I'm going to put in some placeholders here. I'm just going to draw in some boxes. You'll see why I'm doing that here in just a little bit. Okay, so we're going to take the change in our y values. Our y values are 5 and 7. Okay, so I'm going to take 5, subtract 7 on the top, and then my x values are 2 and 4. So I'm going to do 2 minus 4 on the bottom. So if we do 5 minus 7 on the top, 5 minus 7 gives us a negative 2. And then a 2 minus 4 on the bottom, 2 minus 4 is also negative 2. So our rate of change, or our slope, is negative 2 divided by negative 2, which simplifies to positive 1. So the slope of this line that contains the points 2, 5 and 4, 7 is positive 1. Okay, looking at number 8, I'm going to go ahead and I'm going to write out my slope formula. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Again, I'm going to put in these placeholders here. And you're going to see why I'm doing that for this problem. In the last problem, I went ahead and I did 5 minus 7 on the top. So I started with my first point, and then I subtracted the second y coordinate here. You're also allowed to start with the second y coordinate. So in this case, the second y coordinate would be negative 2. And subtract the first one, which should be 4. Okay, so for the top part, really the order doesn't matter. You can do negative 2 minus 4, or you could do 4 minus negative 2. But whatever order you choose to subtract in on the top, you have to keep that order consistent for the bottom. So because I chose to start with my negative 2 on the top, I now need to choose to start with the 3, okay, the 3 that corresponds to the negative 2 on the bottom. So if you do negative 2 minus 4 on the top here, you have to do 3 minus negative 1 on the bottom. And so this is one reason why I'm putting in these placeholders here, these boxes, is so that you don't mess up your signs. Because when we simplify now, on the top we're going to have negative 2 minus 4. That's going to give us a negative 6. On the bottom we have 3 minus negative 1, which becomes 3 plus 1. So I'm going to be really adding there. and I'm going to put down a 4. It's very easy, because there's already subtraction signs in this formula, to forget to add in that second subtraction sign at times. And so it's very easy to say that this bottom part would become 2 when really that's not the case. So that's why I'm having you put in these placeholders here, so that you don't accidentally miss that second negative sign and forget to do a sign change whenever you have a minus negative. Okay, so -6 over +4 is what our slope becomes. That will reduce to the fraction -3 over 2. And again, we're keeping our slopes as either whole numbers or fractions for these problems. Improper fractions are fine as long as they're reduced. Okay, let's look at the next one, number 9. We have -4, -5, and -9, 1. So again, m equals change in y over change in x. Again, it doesn't matter which y coordinate you start with. You can start with the -5 or the 1. This one I'll go ahead and start with the -5. So -5 minus 1. But now that I've started with the -5, on the bottom I have to start with the -4. Okay, if you switch up the order on the bottom, you're going to mess up. So -4 minus -9 is my second x coordinate. Okay, and because I have those boxes in there, now I know I'm going to get my signs correct. So I'm doing -5, subtract 1 on the top. That's going to give me -6. On the bottom, we're doing -4 minus -9. So another double negative. You add -4 plus 9 is +5. So the slope, -6 over 5, that really doesn't reduce, so you just get a slope of -6/5. Okay, I want you to pause the video, try number 10 on your own, and then once you have that, click play to check your answer, please. So for number 10, you could have set this up 2 ways. You could have done what I did, m equals 8 minus 1 over 7 minus -7. You could have also set it up backwards from what I did on the top, and you could have started with the 1 coordinate first and done 1 minus 8 divided by -7 minus 7. Okay, you should have still gotten to the same answer once we reduce. So the way I did it, I get a 7 over 14, 7 minus -7. I'm going to have to do some sign changes there and add. So 7 over 14 reduces to +1/2. Or, had you done it this way down here, 1 minus 8, that'll give you a -7, divided by -7 minus 7 is -14. Well, you have a negative divided by a negative, which becomes a positive, and again 7 over 14 reduces to 1/2. So either way, you get +1/2 for this one. Okay, finally jumping to our last 2 examples. So for these, we're still going to use our slope formula, but I've changed it up a little bit. This time I'm giving you the slope, and I'm giving you 1 point, and our job is going to be to find the missing coordinate from the second point. So in number 11 here, we're missing an x coordinate, and our job is to find what is that x value equal to. So we're still going to use our slope formula. Again, m equals change in y over change in x. But this time, instead of solving for m, okay, we know what m is equal to. M is actually equal to our slope, which is -1/2. So I'm going to plug in a -1/2 for m, and then plug in out of my formula as follows. I know both of my y coordinates. Okay, I have a y coordinate of 4 here and a y coordinate of 8 there. And then for my x coordinates, I know this first one here that corresponds with the 4. This is a 2, so that needs to go down here. The second x coordinate, though, I don't know, so I'm going to plug in an x for that one. So I have -1/2 equals 4 minus 8 all over 2 minus x. Now I'm going to simplify a little bit. -1/2, we can also rewrite that as -1 over +2. You'll see why I did that in a second. Equals, for the top part, 4 minus 8 is just -4. And for the bottom part, I have 2 minus x, which I need to leave written as 2 minus x. Okay? We now have an equation, or more specifically, a proportion. And so this is something we did back in Unit 2. We can solve this proportion for x by cross-multiplying. So I'm going to take my diagonals here, keeping in mind that 2 minus x is really inside invisible parentheses, and I'm going to do some cross-multiplication. So I have -1 times the quantity 2 minus x. That's going to be set equal to 2 times -4, which is -8. And now I can go ahead and solve this equation here for x. So I distribute, I get a -2 plus x is equal to -8. And then finally I can add 2 to both sides. And I know that x is equal to -6. So that means that Negative 6, 8 was the missing ordered pair. Okay, finally for 12, I'm going to do the same thing, except this time I'm missing my y coordinate. Okay, so our formula, again, m equals change in y over change in x. We know the slope is 6, so I'm going to write that as 6 over 1. And we're going to plug in our y coordinates. This time I'm missing one of my y coordinates. I know the other one is 48. And I know both of my x coordinates, so I need to have a negative 4 and a positive 2 down here. So doing a little bit of simplifying, I get 6 over 1 is equal to y minus 48, we just need to leave that alone, all over negative 4 minus 2 just simplifies to negative 6. And so now I can do my cross multiplication. 6 times negative 6 is negative 36. That's going to be equal to 1 times y minus 48, which is just y minus 48. And now I can add 48 to both sides. Okay, so for this one, y is equal to 12, which is our missing y coordinate here. Okay, as usual, if you have any questions in this video or the last video, feel free to jot those down or just send me an email with those questions. That would be fine as well. And then if you need to rewatch anything in either video, feel free to rewind and do that. I know there was a lot of information here in both of these videos, but we're going to be practicing this a lot in the next few days. So hopefully, if it's not clicking yet, it will be once we get some time in class to practice. Until I see you again, have a nice day. You're all wonderful people. Take care.